We're going to look at three methods for dividing with decimals. We're going to look first at the standard division algorithm using long division. Then we're going to look at fraction division, and then finally estimation and reasoning. So if we want to do this division problem, we have 16 and 5,876 10,000ths divided by 2 76/100ths. The first number is going to be your dividend. So when we set this up with long division, we're going to put our long division bar, and that first number is going to go underneath the division bar. And then the second number is your divisor. So that's the one that goes on the outside. So this is the setup for my original division problem. And then basically you can't do this. So the rule is that when you're doing long division, this divisor has to be a whole number. You can't do long division unless that divisor is a whole number. This one, it doesn't matter, right? So the dividend can be a decimal or not, but the divisor has to be a whole number. So what we're going to do then is we're going to make this a whole number. So we're going to move the decimal in the divisor until it's a whole number. So however many spaces that takes. In this case, I would need to move that decimal 2 spaces, right? That would make that 276. But then you can't just move the decimal just because you want to, right? So what you would need to do is however many spaces you had to move the decimal in the divisor, you would need to move the decimal the same number of spaces in your dividend. So even though we were okay with the fact that the dividend was a decimal, we have to move it the same number of spaces. So this becomes 1,658 and 76/100ths. So this original division problem has been replaced by this equivalent division problem. So one of the common mistakes that I see here is that a lot of people think that when you're done with this, that you have to like do something to get back to what you did. You do not have to do that, right? So this is an equivalent division problem. Whatever the answer was to your original division problem, the answer will be to this one. So we can just solve this new division problem where the divisor is a whole number and the answer will be the same. I don't need to do anything to it in the end to get it back, right? As long as I did the same movement to both the divisor and the dividend in terms of the decimal, then these are equivalent. So I'm going to basically just do this new division problem, which is this 1,658.76 divided by 276. All right, so I'm going to do this and I'm going to see how many times my divisor goes into my dividend. I do not need to necessarily use the whole dividend. So I would just try a digit at a time. I would say, well, will it go into 1? Well, 276 definitely won't go into 1. So then I'll move over another digit. Will it go into 16? It won't. Will it go into 165? Unfortunately, it won't. Sometimes it will go into 3 digits, right? Depending on what you have there. And so then I'm going to have to move over to the 4th digit and I'm going to have to try and figure out or take a guess at how many times 276 goes into 1,658, right? And this is not something you're expected to know, guys. I don't know off the top of my head how many times 276 goes into 1,658. And I think it's really kind of disheartening if you're ever in a class where the teacher asks that question, how many times does 276 go into 1,658? And somebody just shouts out an answer that's right. And you're like, well, how in the world did they get that? Guys, they either did it ahead of time or good for them. They just are really, really good. For me, I don't think that most people are like that. So this is really just, some educated guessing. So 276, what you might do is you might kind of round it. And you could maybe take an educated guess based on that. So like 276 is reasonably close to 300. I know 300 times 5 would be 1,500, right? And that's pretty close to this, right? So 5 might be a good guess, or something close to 5. You might try 4, you might try 6, and you just try it, right? So I'm going to go ahead and try 5 because that's my guess here, just because I know 5 times 300 would be 1,500, and this is kind of close-ish to 300. But it may or may not work. The nice thing is that if you try something and it doesn't work, it should kind of point you towards what will work, right? So I'm going to go ahead and multiply this. And when I multiply, I'm going to multiply a digit at a time. You don't have to do 5 times 276 in your head. I can do 5 times 6, 5 times 7, 5 times 2, and regroup, right? So 5 times 6 is 30. So I'm going to regroup my 3. 5 times 7 is 35, plus 3 is 38. Regroup my 3. 5 times 2 is 10, plus 3 is 13. And I'm not sure if that works. I might need to go ahead and do the subtraction here. So 8 minus 0 is 8. This would be regrouped. So then 15 minus 8 is going to be 7. 5 minus 3 is 2. Oh man, that was not the right choice, right? So 5 was not the correct choice. Now, how do I know it wasn't the correct choice? Well, if I had gotten something bigger than 1658, like let's say instead of 1380, if I got 1780, that would have been bigger than 1658, meaning I can't subtract. So that would have told me I picked too big. In this case, what I'm left with is bigger than 276. So I can see 276 would actually go into that again. So that's how I can tell that I didn't pick big enough, right? So 276 will go into 278, which means this will go in one more time. So it's unfortunate that it was not a great guess, but actually it was a good guess, right? Because it pointed me towards the right direction. I can see here that, oh, it should just go in one more time. So from this, I figured out that this actually goes in 6 times. Notice when I'm writing that 6, I'm putting it above the 8, right? And it would be good here to go ahead and bring my decimal up. Lining things up is important when you're doing this with decimals. It's not as important when you do it with whole numbers. All right, so I'm going to erase what I did before that was not correct. So you definitely want to use something that erases. And then I'm lining up my decimal, and then since I'm not going into 1 or 16 or 165, since I'm trying to do 276 into 1658, that's why I'm making sure I write this above my 8. All right, so then let's go ahead and do the multiplication. 6 times 6 is 36. 6 times 7 is 42, plus 3 would be 45. 6 times 2 is 12, plus 4 is 16. And that's not bigger than what I had, than 1658, so I know I didn't pick too big. And when I subtract, what I'm left with is 2, which 276 does not go into. So that's how I know that I picked correctly. And this so far is 6. All right, and then I'm going to bring the rest down. And I'm going to keep going, right? So I'm going to go ahead and bring down the 7 and the 6 and keep doing this. And with decimals, we keep going either until it repeats or until it stops, right? Until we get a remainder of 0. Now I can already see here 276 and 276. I know that this goes in once. However, you have to be careful here. So 276 doesn't go into 2. It also doesn't go into 27. But I'm missing a digit in this spot, right? So I need to put a placeholder 0 here. And that's really the same thing as saying that 276 goes into 27 0 times, right? And if you want to show that you can, 0 times 276 is 0 and then subtract, but you don't have to necessarily do that. You just have to remember to put that placeholder. And then 276 goes into 276 once, but that 1 has to line up here, right? And then 1 times 276 is 276. Subtract, I get a remainder of 0. And that's how I know that I'm done here. So with the standard algorithm, we got an answer here of 6 and 1/100th. So then real quick, let's talk about why this works. So the reason that this process works is equivalent fractions. So we started with 16 and 5,876 10,000ths divided by 2 and 76/100ths. But we can think of division as a fraction, and we've done that a lot, right? Division bars are the same things as fraction bars. So we can just think of this as that number over 2 and 76/100ths. And then we would never write a fraction that way, right? So we don't leave decimals inside of our fractions. So then how would we fix that? Well, we might multiply the top and the bottom by something, we could at least get that denominator to be a whole number pretty easily. So what would I multiply that denominator by to get it to be a whole number? Well, I know that multiplying by 10 moves the decimal, right? Or powers of 10. And so if I move that decimal 2 spaces, that would make it a whole number. That would take multiplying it by what, 100? So if I multiplied that bottom number by 100, then that would get it to be 276. And then I would have to do whatever I do to the bottom, I'd have to do the same thing to the top. And so then this is, move the decimal 2 spaces on that one as well. And we get that, which is really 1,658 and 76 divided by 276, which was our equivalent division problem, right? That we did in green. So that was the whole idea. So this whole idea of however many spaces you move the decimal in the divisor, you have to move the dividend the same number of spaces. That really comes from whatever you do to the bottom of your fraction, you also do to the top, right? So I have to do that in order to keep it equal, right? Multiply by 100 on the bottom would make it a whole number, but whatever I multiply by on the bottom, I would do also to the top. So we get this equivalent division problem from this idea of fractions and getting the same thing, doing the same thing to both the numerator and denominator.